All right, Algebra crew, moving on to section 11.6, inverse variation. All right, we learned direct variation a long time ago, back at the beginning of the year. And so now we're getting to inverse variation. And, reading this section, the only thing you really need here is your form of the inverse variation, which is x times y is equal to k. All right, and this k is the constant of variation. Okay, just like before. And you can solve this for y, so you could also write it as y is equal to k over x. Okay, either way, we usually use this one more often though. X times y is equal to k. All right, so I'm just going to go through a few of these problems on page 702. All right, number one is very easy. All right, it just says, suppose y varies inversely with x. So y is equal to -3. X is equal to 17. What is the equation for inverse variation? Well, what we need to do first, all right, first off, we need to find out what our constant is, what our k is. So guess what? We just plug these numbers in for x and y. So we have 17, which is x, all right? Your y is -3, and that is equal to k. All right, so 17 times -3 is -51. So -51 is equal to k. You aren't done yet, though. Okay, this is what your constant is. They want it in equation form. So the correct answer is, and I'll use a different color here to make sure I look all fancy-pantsy, x times y is equal to -51. That would be your answer. Okay? It's fairly simple. That's what you do for all of those types of problems. All right, now, number two. Number two says an 80-pound weight. So we have an 80-pound weight is placed on a lever 9 feet from the fulcrum. All right, and if you don't know what a fulcrum is, or if you need a picture, there's a nice picture on page 699 with the elephant. The fulcrum is the little green thing. You're trying to balance this beam, okay? So you have an 80-pound weight, and it's 9 feet from the fulcrum. So you do 80 pounds, all right, times the amount of the distance away from the fulcrum, which is 9, all right? And so that now they need to know what amount of weight should you put 6 feet from the fulcrum. So we don't know what the weight is, but it needs to be 6 feet from the fulcrum, okay? So we need to determine how much weight do we put 6 feet away in order for this beam to be balanced, okay? Or the lever to be balanced. These are really interesting things. All right, everybody is always trying to determine your balancing point. All right, and you can do that with anything. You know how, like, if you go outside and you take like a shovel out of your garage and you rest it on your finger, all right, and you move your finger back and forth, either closer to the handle or closer to the shovel blade, all right, so that you can balance it. That is what we're doing here. And you can solve that problem using this technique. All right, so I go to my trusty calculator. 80 times 9 is equal to 720. This is obviously 6x. So we divide both sides by 6 is 120 pounds. All right, so you would need 120 pounds 6 feet away, all right, to balance that beam. All right, now, the next one, graphing, okay? And the graphing problems are actually relatively simple because there's only two ways that these graphs can be, all right? And if you, once again, if you are looking through your book, all right, remember direct variation is linear, all right? Everything is a line. For these, the inverse variation, you get two curves, okay? And for our problem number 3, they say, what is the graph of y is equal to 10 over x? And this is an inverse variation, all right, like up here, all right? So my constant is 10. Now, if your constant is greater than 0, all right, so let's get my x and y axis here. All right, and I'm not going to get too fancy with this, and you can always graph this on a calculator, all right? But you are going to have limits. You're going to have areas of your graph that are undefined, because what happens on a t-table if you were to put a 0 in for x? It's undefined. It's in the denominator. So we're never going near 0, okay? So you can have one of two graphs. And if your k, which in this case is 10, if it's greater than 0, all right, which in this example, it is greater than 0, your graphs are going to look something like this. Notice how it stays away from 0, and then you're going to have a graph when your x is negative. But notice how it is not defined at 0. Now, if your k was less than 0, then your curves end up, all right, so this here is the correct answer for our problem, because the k is greater than 0. Now, if k is less than 0, and I'll just do a tiny graph right here. Here's my x and y. Get my Dayton Flyer colors. Then these are the curves you're going to get. Okay? That's if k is less than 0. This is if k is greater than 0. Okay, so this would be your answer here. And this is just a rough copy. You can always check with your calculator too. You can graph on a graphing calculator. All right. Now let's look at number 4. So remember our inverse variation is x times y is equal to k. All right? And remember, direct variation was y over x equals k. So let's get, we'll just use this color. Okay? And they give us a t-table, x and y. And we have -3, 6, -6, 12, -9, 18. Okay? So remember, direct variation, we had y is equal to k times x. This is direct variation. This is inverse variation. This is direct variation. So y over x is equal to k. So we need to check this this is our direct variation. And we need to check x times y is equal to k. This is inverse. Because this problem is saying, does this table represent direct variation or inverse variation? And then what's the equation? Okay, so when we do this problem, I'm going to check inverse, x times y. So I need to multiply my x times y. So -3 times 6, -3 times 6, that equals -18, right? And then we get -6 times 12. All right, so -6 times 12 is -72. And then -9 times 18. All right, and honestly, at this point, I could have stopped because I don't have the same numbers yet. So that's negative 162. These k's, these are all different. This is not inverse variation. So let's check direct variation. Y over x. So 6 divided by negative 3 is equal to negative 2. 12 divided by negative 6 is equal to negative 2. 18 divided by negative 9 is equal to negative 2. These are all the same. My constants are the same. So this is a direct variation, and they want me to write my direct variation just like this. Y is equal to kx. Well, what's my k? It's negative 2. So my answer here, y is equal to negative 2x. All right? So that is your inverse variation. Make sure you watch this video a couple times if it's kind of tricky. A lot of these problems, though, they're very simple. All right. Hopefully everybody's staying healthy, making our way to that last week of school next week. All right. So hopefully we can get some extra credit quizzes next week.